Our next method of solving quadratic equations will be through a process called completing the square. Now, in order to complete the square, you need to be very familiar with perfect square trinomials. So just go back and kind of refresh your memory on a perfect square trinomial a little bit. If you recall, a perfect square trinomial is a trinomial that could be broken down into two perfect squares, so x plus 2 and x plus 2 in this case, and since they're the same, we can write them in what we call a binomial squared. Now, this perfect square trinomial has this very specific pattern that goes along with it. And so what we're going to do is to try to show you a process in which you can create and develop that pattern. Now, just give you a quick example. If I gave you x squared plus 6x, and I wanted you to fill in the blank so as that we had a perfect square trinomial. Now I'm just going to leave these areas blank for right now. We're trying to create a perfect square trinomial with x squared plus 6x, and then what do we need to add to that? If you recall that whatever two values we need here in the highlighted areas, they have to be the exact same thing for it to be a perfect square trinomial. So they have to multiply to get that number. So we got to think of two things that multiply together to get a number, so they are squared. And they also have to add up to get the middle term. And so if we think about this backwards a little bit, you could say what two numbers actually that are the same add up to 6. And so if we're looking at all the values that add up to 6, we've got 5 plus 1, we've got 4 plus 2, we've got 3 plus 3, and of course, you don't want to forget about 6 plus 0. And we're looking for the two numbers that actually add up to 6. So I'm actually going to kind of back my way into this. So you can see I'm going to have a 3 here and a 3 here. And 3 plus 3 gives me 6. But if we were to FOIL these together, the 3 plus 3 would actually give me a 9. And so the 9 is the value that would actually create this perfect square trinomial. Now, if we look at a different problem, we may be able to see just a little bit more clearly what we're dealing with here. If I have x squared plus 5x plus blank, and I need to figure out what two numbers add together to give me that 5. So I need two numbers here that add together to give me that 5. And keep in mind, those numbers have to be the exact same number. Well, you can see very clearly that we're not going to have two numbers that are exactly the same unless we go into decimals or fractions. And so many of you may be thinking to yourself, oh, what about 2.5 plus 2.5? And that's absolutely correct. However, what I would like you to do is think of this as improper fractions. So 2.5 is the same thing as 5 halves. So we're going to say 5 halves and 5 halves. There. Now, if we need to know what that number is that we're going to add to make this a perfect square trinomial, it's actually 5 halves times 5 halves, which is going to give us 25 over 4. And I know this can look a little funny, but x squared plus 5x plus 25 over 4 actually is a perfect square trinomial. Now what I want you to recognize right here before we get into notes is look at this relationship between here and there. That b value is being written over 2, and then it's being squared to get the 25 over 4. So if you think about this, if we took 6 and wrote it over 2, that would give us 3, and then of course the 3 squared would be 9. And so we can come up with a little pattern here that if we take our b value, write it over 2, and we square it, that's going to equal the c value that we're trying to use to complete the square. Now, if we go back to the notes, you can see this process in a visual nature, and you can see clearly why we call it completing the square. If I take the b value over 2 and I square it, it completes this square, this visual square that we've created with the x's and the b value. So if we give you a b value, we should be able to use that to complete the square using the formula for c equals b over 2 squared. So let's take a look at an example problem. You can see here we were given x squared minus 7x plus c, and we were trying to find that c. And of course, we just simply gave you a formula for that, and you could just plug it in. Now, it's very important for what we're going to be doing later that you write this as a binomial squared. So you would say x minus 7 over 2 squared. So let's try to work a problem on our own. Let's go down here, sample problem number 1. It says find the value of c that makes x squared minus 3x plus c a perfect square trinomial. So take a second to try that. Basically what we were trying to do is what we were trying to do on the previous page. We're trying to find the number that makes this a perfect square trinomial. Notice here that this is a negative number, so these two values also have to be negative, and that makes the binomial negative. However, we still follow the same process. Two numbers that add together give us 3, and so in this case we're going to be having a decimal or a fraction, so this is our b value over 2, which is this value. But in order to get that perfect square trinomial, we need to square this. And so that's going to equal to 9 over 4. So 9 over 4 is the c value that makes this a perfect square trinomial. Now, make sure you practice this process a little bit. Of course, put negative here if you want to do that. Practice this a bit. We're going to be using this process to solve quadratic equations in the next part of the notes. Now that we've learned completing the square, we're going to use this process to help us solve quadratic equations. Now, in past lessons, we've learned how to solve quadratic equations through factoring and square roots. However, we're going to see that at times we're going to get a quadratic equation that can't be factored, nor can we use square roots. So this is where the completing the square process is going to allow us to solve any quadratic, no matter what the form of it is. So first thing we have to understand and we have to take care of is that the leading coefficient has to be equal to 1. So if we have ax squared plus bx plus c, and let's just say that equals to 0, this leading coefficient needs to be equal to 1 for us to complete the square. And if it's not, we're going to need to divide everything by that number. Now, this may create a fraction along the way that we may have to deal with, but we'll start off with a more basic example that has a leading coefficient of 1, and let's see how we would use completing the square process. The first thing we're going to do is recognize that we cannot factor x squared plus 10x minus 3. Nor can we use square roots because it has a b term. So since this is not factorable, what we want to do is we actually want to move this 3 out of the way, and we do that by adding it to both sides. And this leaves us x squared plus 10x on the left side by itself. And of course, that should look similar to the setup that we were just using to complete the square. Now, in this process, we are going to complete the square, and we're going to have 5 squared, or we're going to have 25. Now, we would add that to x squared plus 10x to make a perfect square trinomial. Now, the important thing here you have to remember to do is that in the golden rule of algebra, it says to keep the equation balanced, whatever you do to one side, you must do it to the other side. So it's very important that you add that 25 to the other side as well. And so then we factor that perfect square trinomial to a binomial squared. And you can see we have x plus 5 squared equals to 28. Now, we've seen problems like this before. So we can take the square root of both sides and get rid of that square, and then work down until we have it in the most simplified form. So x equals negative 5 plus or minus 2 times square root of 7 would be our final two solutions. So completing the square can be very useful, and it can be used for any quadratic equation as long as we can get that a, or that leading coefficient, equal to 1. So let's move on down to sample problem number 2. We have two problems here actually that you can do. Sample problem number 1 and then sample problem number 2. Now, they're going to give you a couple different looks at two different types of completing the square problem. So go ahead and try to work problem number 2 and problem number 3 real quick. Okay, let's take a look at this. At first glance, you might see the 8 and say, oh, negative 2, or 2 and 4 could multiply to get 8 and then add up to get 6. The problem is the signs give us an issue. We don't have two values, it would be able to give us a negative 8 and a positive 6. And so we're going to have to use completing the square here. So what we're going to do is we're going to simply add 8 to both sides and clear some space. Now, what I kind of like to do is actually give myself something to fill in. And then, of course, if I add something to the left side, I have to add it to the right side. And so we've seen x squared plus 6x before. We did that on this previous problem where we had the 3's and added up to 9. So if you were using the little formula we gave you, that would be 6 over 2 squared, which is 3 squared, which equals to 9. So we're going to add 9 to both sides, which is going to give us x plus 3 squared, or you could do x plus 3 times x plus 3 first if you feel more comfortable. And now it's equal to 17. Now we have a binomial term squared, we can actually take the square root of both sides. And of course that cancels out the square. So we have x plus 3 equals to plus or minus the square root of 17. And then we want to get x by itself. Remember, we want to write this negative 3 in front of the plus or minus. And since 17 can't be simplified, square root of 17 can't be simplified, we have our final two solutions. So that's a basic completing the square problem. Now if we look at sample problem number 3, we run into a different problem. We have a leading coefficient, but that's not equal to 1. So like I told you before, you may need to divide this value out. So we're going to divide out the 5. And if we do that, we have to divide everything out across the board. Now, get a little lucky here. When we do this, we're left with a trinomial still equaling to 0. And now I can move the 6 out of the way to give myself room to complete the square. And so if I want to complete the square, my c value is negative 2 over 2 squared, which is negative 1 squared, which is equal to 1. So I'm going to simply add 1 to both sides. And this will be x minus 1 squared equals to negative 5. And if you want to look at this value right here, after the b has been simplified with 2, that negative 1 is what's going to pop up in that binomial squared. Take the square root of both sides and get x minus 1 equals plus or minus the square root of negative 5. And if you remember, we cannot have a negative square root in there, or negative value under the radical. So this is going to break up into square root of negative 1 and square root of 5. So that's where we get the imaginary number from. Okay, and there are two good examples of completing the square to help us solve quadratic equations.